right, so after we found it graphically, then we found it, no, not algebraically, not technically, because can we actually plug in an infinity and have it solved? No, but can we, like in quotation marks, can we visualize, intuitively try to deduce? Which is kind of weird because you're intuitively, but then you're deducing, but you're kind of using like what you know of math. Anyway, you can't plug in an infinity, but you can plug in the idea of approaching infinity, which is where we first started getting answers. But then, all right, Nick, now you can answer. How do we do it next? Algebraically. Now, guys, help me out. How did we know what to multiply creatively by 1 by? 1 over x to the highest degree in the numerator and or denominator. The highest one, like the one with the most magnitude, right? So then when we multiply by 1 over x to the 5th over 1 over x to the 5th in the top one, why did these all go to 0?
That's our rules.
Because graphically we looked at it. Any constant over x to any power, what will the limit always be? Don't go into anything. Minimize everything that's because the limit of any constant over x to any power is 0, right? So we said, as long as it's over an x, let's just make it go to 0, 0, 0. Oh, we didn't finish it. It's coming. All right. Once we multiply by 1 over x to the 5th, we got a number over 0, which was infinite. We just had to check the sign, right? Why was this one negative? Who wins, the 7 or the 6 times 1 infinity to the 5th? Yeah, he wins. So he's going to be a negative. That's always going to be a positive. So therefore, that's how we checked. All right, number 17. We didn't actually get to finish, but we're going to quickly finish it now. We got an answer, but we didn't see the algebraic way. So what I was doing is I was going ahead and multiplying top and bottom by 1 over x to the highest degree, technically under a cubed root if I was to do it algebraically. What's going to end up happening, I'm going to have a cubed root of the limit as x goes to infinity. Oh, that's why I didn't have to, because I had the cubed root out there. That's okay. Let's go ahead and pull it back in, because that's how I'm doing it now. So the limit as x goes to infinity of the cubed root. There you go. Cubed root times a cubed root is just a combined cubed root, so therefore I get 2 over x squared plus 3 over x minus 5 all over 1 over
X to the 5th. X to the squared.
1 over x cubed, right? Or x squared, because I'm just distributing. So 1 over x squared and then plus 8. So what ends up happening? Algebraically, he goes to?
0.
He goes to?
0.
He goes to?
0.
What do I have left?
Say that one.
Now some of you guys might be getting confused by my little 3s that are here, and they might be like, what? What's going on? Okay, there we go. That's the cubed root. That's the cubed root. So it's like I'm multiplying this. The 3s were kind of confusing me for a second. They were too close to the rest of it by this. So another way, a very, very algebraic way. Now, number 14, let's do one more. Although I don't want to go looking at my book for it, so I'm going to go steal it from the other class.
Plagiarism is as 1 over x.
Yeah, the limit as x goes to infinity of 1 over x to the 12. There we go. The limit as x goes to infinity of 1 over
x minus 2.
All right, cool kids. If we were to do it algebraically.
1 over x.
1 over x.
Yeah, on top and on
bottom.
What ends up happening?
0.
1 over x over.
Skipped ahead, but yeah. Remember, I have to distribute, right?
So x. No, x. I don't know. 1 x.
Hold on, pause. Does the math make sense?
Yeah.
So 1 times 1 over x. Distribute x over x. 12 over x. Who's going to 0?
That one and that one.
0 over 1 equals, some of you get confused on this, equals what?
0.
Got it. What wouldn't work? 1 over 0. But 0 over 1. 1 times what is 0? Oh, 0. 0 times what is 1? Oh, nothing. Okay, now this is all algebraically. Here's the horizontal asymptote tests that you guys did in the summer packet. You guys did in Algebra 2. You did in pre-cal to some extent. This is a shortcut. The shortcut for limits to infinity when we're dealing with rational functions, which is basically all we've been dealing with up to this point. So if I have a rational expression, remember polynomial on top, polynomial on bottom. If the top wins, can you guys recall?
It would be.
You could look at number 25 to help you
0,
out.
0. Oh, infinity.
If the top wins, what's going to end up happening? It's going to be uninfinity. I just have to check my sign. So I'm going to say positive or negative infinity. I'm going to say check the signs. So if the top wins, it's like I'm having a constant over 0. I'm having an infinite form. If the degrees are tied, if you guys want to look, you can look at number 17 on the page before.
Leading coefficient.
Yeah, the ratio of the leading coefficients. Technically, I'm still going to say, even though we're going to look at a way to not make it so ambiguous, I'm still going to say check the signs. Did you look online over the weekend? You. It's already filled out? Yeah? That's closed status. If the degree of the top is less than the degree of the bottom, you're going to end up with 0 over a constant in essence. Oh my goodness, everything. Period. Welcome to Fifth Period, our daily iTunes reminder. Thanks, Marcia. Yeah, the problem is I don't have an administrator right, so to do it, I need Mrs. Christensen, and it's always when I'm teaching.
She's across the hall.
She is across the hall. All right, the limit. Jez, really, there was no sarcasm. Maybe a little bit. Degree of top is less than degree of the bottom, so who wins? The bottom one. The dividing factor. And if as I go to infinity, I'm dividing it more and more and more and more. If I have a whole pizza and I'm dividing it into smaller and smaller and smaller and smaller and smaller and smaller and smaller pieces, what's my piece size going to?
0.
Very sad. True. 0. No checking the signs on a 0.
No.
So if you guys notice, we just did an example like each and every one of those 3 degree tests. True? True. Let's go ahead and do some more examples. You ready?
Ready.
Nick, go ahead.
Never mind.
You sure?
Sorry. Yeah.
Okay. We're asking ourselves which magnitude wins. Which one is the strongest? Because that one is going to determine what my limit is going to equal. And remember, if I have a limit that exists that equals a constant as I approach, as I increase without bound, approaching positive infinity, or decrease without bound and approaching negative infinity, I also have a
Oh, I didn't hear the question here.
if I have a limit as I approach positive or negative infinity that exists, there also exists a what at that y value.
Horizontal.
Got it. Okay, here we go. So, technically we could go ahead and add that in. And that's something that we did not do in period 1, so haha.
We're better.
We're ahead of them in one respect. Okay. Both of these would have horizontal asymptotes. He definitely would not. But you would have one at 0. You would have one at the ratio of the leading coefficients. All right, cool kids. Let me stretch your minds a little bit. I want you guys to go ahead and take a minute using either the degree tests or an algebraic way, or maybe just using your own logic, but not someone else's. Jose Francis. I want you to make your best hypothesis, your best educated guess as to the limit. You have it. Okay, hold on. Yes, it's x approaching negative infinity. If you want me to, I will zoom in now. Not now. Now. A little fuzzy, I apologize. Best educated guess. You can make it quickly with degree sets. You can make it a little bit longer with algebra.
Even if it's under the radical to see, even if it's under the radical, you could still use the degree test.
You just have to be careful. You're going to see it this time. Had a few of you guys with possible answers. All right, Emily, what was yours?
3.
Okay, we have a hypothesis of positive 3. Any more hypotheses?
9.
9.
3.
Another 3. Any other hypotheses?
2. We all got it wrong.
All right, let's see. I'm not telling you yet. Let's see.
You look disappointed.
If we were, I was just saying if there are more hypotheses, but I guess we all agree on one of these.
I'm gonna go with
Here we go. You ready?
3.
No other hypotheses? Looking at a few of my...
Can I guess 2?
Laura, what do you got? What is it? 0. Okay.
I put 2.
2? No, we're not going to put 2. Okay, come back. Ready? Here we go. Let's go ahead and do it the algebraic way. Okay? Let's do the algebraic way. Question. What is the highest degree of an x?
X squared.
No.
Just kidding. 1.
Why is it 1?
Because it's square root of 2,
So really the square root of x squared is the highest degree. Is that true? So if I was to multiply right? Then I could go ahead and say, I think all of you agree he was the highest. Hold on, wait, but he has a square root. Hence why I'm multiplying by 1 over the square root of x squared. Now those of you who guys were like, just simplify that. Okay, if I have 3x over the square root of x squared, a square root times a square root, or times the reciprocal of a square root, I can bring it all together. So I'm going to have x squared over x squared minus 4 over x squared. Question, who's going to 0? Which we knew that, because he's not going to be near as strong as negative infinity squared, right? Okay, hold on. What's the square root of 1? As I go to negative infinity, square root of 1 is still what? 1. So now I'm left with y. Because it's a root. If I plug in a positive or negative 2, aren't they both going to square it equal 4? And both have a square root of positive 2? Wait, so I plug in a positive, I plug in a negative, I get out a positive? Do I have to have him? Yes. Now, some of you guys might look at this and be like, oh, hey, the degrees are... Weren't the degrees technically equal here?
Yeah.
Because it's a squared under a square root, which is really the same thing as a linear, right? A linear in the sense of degree. So the degrees were tied. So I think right now we can kind of get rid of both of these, right?
Yeah. I was right.
I really felt mine.
Hold on. Let's see. How can I, though, reduce x with absolute value of x? Isn't absolute value of x the exact same thing as a piecewise function? Where it's itself as long as x is greater than or equal to 0, but it's opposite if x is a negative. So something from Algebra 1, my ones who I had you way back then, or it should have been from pre-cal last year. Wait a minute. Which domain restriction kind of fits with me approaching negative infinity? Negative infinity, man, I'm going to be going less than 0 eventually. And for a long, forever after that. So then what can I replace Absolute value of x4 if I'm approaching negative infinity.
Negative.
Why did I say check your signs? For tricky problems like this. My ones who thought it might be 3, good job. My ones who didn't, still thank you for participating. However, coming back, check your signs. Now, if you want to think about it another way, could some of you guys maybe, if you realize the degrees were tied, come to a different conclusion or come to the 3 conclusion pretty quickly without any of that math? Ratio of leading coefficients, 3 over root 1 is 3. If only there was an easier way to check my signs. It's not going to necessarily get me an answer, but it will let me see my signs. What's the top going to be?
Negative.
What's the bottom going to be? 4 isn't going to win, right? Who's going to win? The infinity is, so a negative squared is a positive, square rooted is a positive. What's my sign going to be? So maybe you can get there a bit faster?
But, yeah.
Possibly? Possibly a bit faster? Okay, how about another one? Same dealio. Take a minute. The exact same problem, just one's approaching negative infinity, one's approaching positive infinity. Take a minute, try to make your best hypothesis. This one's a little more obvious because there's an absolute value in the question itself, and yet you can deal with it the same way. Maybe with a shortcut, maybe with algebra. The important thing is, can you get to the correct answer? Remember, there are note checks in this class, and so if you are not taking notes in your composition book, get them in there. Remember to be updating your table of contents. You're trying each of these problems. How many people have at least a hypothesis for each of them? Maybe not all the way solved, but at least a hypothesis. All right, 30 more seconds. At least get a guess in there. At least write down a guess for each one. At least a guess, if not a solved out answer. At least a guess. Jessica, what's your guess for the first one?
Positive root over 2.
Sterling, what's your guess for the second one?
Negative 3 over.
Does anybody disagree and have a reason why? I just put down guesses. Or any other answers for the first one that you might think? No bravery whatsoever?
No. Well, what if we all agree on the answer?
You might. But I don't think that's written on everybody's single, like every single person's paper was those
I
two.
could guess something completely ludicrous if you want.
No, thank you. Tone it down. All right, kiddos, on number 2. How many of you guys used an algebraic method to try? How many of you guys used a shortcut method to try? I'm going to do both real quick. If you were to use the, let's just say the algebraic, because my shortcut people, that's all well and good as long as they're getting right answers. But hold on, let's just make sure that there's proof as to why this is or isn't 3 halves. So if I was to use the algebraic method, How could I break apart this absolute value? This is the only way to break it apart. It's either going to be the opposite or it's going to be the exact same thing. Question, what's my separator between the positives and negatives? The 0. The 0. But not actual x equals 0. Because if I plug in 0, isn't that a negative number? If I plug in 1, that's a negative number. 0 doesn't separate. But the 0 of the argument does. What's the 0 of the argument? 0. So hold on. Wait, which one's which? If I plug in 3, which is greater than, is that going to be a positive or a negative expression? Okay, so greater than and then less than. Question. Which one am I approaching for the first one? So therefore, I could replace, technically, if I wanted to, using, hey, I'm approaching negative infinity. It's going to eventually, if not right away, fit into this first one. So therefore, I could say this is the same thing as the limit as x approaches negative infinity of 6 minus 3x all over negative. Degrees are?
The same.
And now that I've broken up my absolute value for sure, a negative over a negative is a
Positive.
And ratio of leading coefficients. You guys were correct. Could you have also checked your signs and plugged in a negative infinity? A negative times a negative is a plug in a negative infinity absolute value. A positive over a positive is a positive. Multiple ways of checking the signs. Just make sure you have a way that works. How about the bottom one? Let me do it the other way. So not the algebraic, not the plugging in. Let's do it the degree test way. All right, degree test way tells me the degrees are the same. However, I need to check my sign. So therefore, I can say, all right, to check my sign, 6 minus 3 times negative infinity. Nope, positive infinity. All over. This is my soft math, right? Just kind of pretending that I can get a sign out of it. Who's going to win, the 6 or the 3 times infinity? What sign is he going to have?
Negative.
What's coming out of my absolute value? So what's my sign? So whether you do it with the actual algebraic and then plugging in and then taking the limit, or whether you take it more as a concept and say, hey, degrees are tied, awesome, ooh, what's a sign? Both ways technically work. Good job, both my volunteers and the others who agreed with them. Questions on those? Nick, go ahead.
For the first one, in the denominator, in the red part, you used the negative 2x minus 4 because it was negative infinity?
Yeah.
Okay.
So even, could I start approaching negative infinity by plugging in x as 100? Yes. But as I go to negative infinity, which domain am I going to have to end up using?
Okay, yeah.
Does that make sense? All right, cool kids. So then, let's do some easy ones. Oh, don't worry. Let's do some easy ones. We're going to go kind of quick, though. I'm going to give you a couple seconds to write down each of the 3. Just get me 2 lines in between each. If you think you totally have this solid, get me 1 line in between each. Not going to give you as much time on these ones. So 60 seconds to write and to solve. Hopefully using a shortcut. Go ahead. Can I zoom? Yeah, this one might be hard to see, but yeah. Write down each, make a hypothesis for each. Write down each and make a hypothesis for each. What do you guys get as a sign of the infinity on the first one? Positive. A negative cube times a negative over a negative times a negative. Careful. Careful. Number 5, what'd you guys get?
Negative.
Yep. Ooh. Not a positive. Because it's minus x squared. So it's going to be 5 over negative 1. You could try to plug in to test your signs. They'll still be a positive over a negative. And then number 6, what'd you guys get?
0.
Because who won?
The bottom.
Bottom.
Good. All right, kiddos, we got a lot more practice in with our limits at infinity. Sadly, for sake of time, I can't take any questions on that page, but I will be here after school, maybe with a slight interlude because I have a quick parent conference. But there are 2 things I want to talk about real quick with limits at infinity. If we can get through these 2, we'll be tied to period 1, we'll be good. Okay, trig functions. What if you had to take the limit as x approaches infinity of sine? What's the limit as you go to infinity of sine?
0. I don't know.
Think about your sine curve, right? It's up on the wall.
1.
What's going to happen? Is it going to 1? Is it getting closer and closer to 1?
No, awesome.
It's oscillating and oscillating and oscillating. It's not getting closer and closer to anything. It's going between 1 and negative 1, but it's oscillating. So what's the limit? Does not exist. It's not approaching a set constant. Same thing with tangent and cosine now. When you start putting those into expressions, you have to think about who wins and who's stronger, the top or the bottom. Exponential and logarithmic, to help us out with those, use their graphs. I say a to the u because it could be 2 to the 2x. It could be 3 to the x minus 1. In general, exponential functions, logarithmic functions, in general, they could be transformed a bit. Behave like such. Now the limit of both as they go to infinity is what? Where are they both going as they go to infinity, guys?
Positive.
Yeah, they're going up, right? They're going up, 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 up. So both of their limits are infinity, but when you start like using them in rational expressions like a to the u, like 2 to the 2x over x squared plus 1, who's stronger? He increases quickly. So he's one of the strongest functions in the sense of magnitude, and he increases fairly slow. Now, I'm not saying that to necessarily lead you right in every single problem, but it is something to think about as you take limits to infinity. All right, kiddos, with that, we end our section 2.3. Tomorrow, if you are not done yet, is our homework number 7 due. AKA, we might have a homework check tomorrow. Just a minute. We will start tomorrow on continuity 2.5. Bye, guys. I'll be here after school. If I'm not here when you come at like 3-ish, I'll be here until like 5-ish. So check back a little bit later. There are extra photo forms at the front if you need them.
Sterling.
So did you get the circle answers though?
We want.